Un, deux, trois. Et maintenant, je te réveille. Chapitre 3. Excusez-moi. I'm sorry. I just got off Duolingo. Let's go. Allons-y. Here we go. Here's the big picture. We've finished module 1, module 2, and which was really short. This one's going to be a bit longer. We're going to look at module 3. So let's get going into implement computer vision solutions. Big picture, computer vision is an area of artificial intelligence that deals with visual perception. Azure AI Vision includes multiple services that support common computer vision scenarios. The Azure AI Vision service gives you access to advanced algorithms that process images and return information based on the visual features you're interested in. The major categories are OCR, image analysis, face, and video analysis. So let's break them down. This service can extract a wide variety of visual services from images. For example, it can determine whether an image contains adult content, find specific brands or objects, or find human faces. Use image analysis through a client library SDK or by calling the REST API directly. You can analyze images to provide insights about their visual features and characteristics. All of the features in this table are provided by the Analyze Image API. If not called out explicitly in the exam objectives, I wouldn't worry about knowing this list completely. Detect objects. Object detection is similar to tagging, but the API returns the bounding box coordinates for each tag applied. For example, if an image contains a dog, cat, or person, if an image contains a dog, cat, and person, the detect operation lists those objects together with their coordinates in the image. You can use this functionality to process further relationships between the objects in an image. It also lets you know when there are multiple instances of the same tag in an image. It's important to note the limitations of an object detection so you can avoid or mitigate the effects of false negatives or missed objects and limited detail. Objects are usually not detected if they're small, less than 5% of the image. Objects are usually not detected if they're arranged closely together. A stack of plates, for example. Objects aren't differentiated by brand or product names, different types of sodas on a store shelf, for example. However, you can get brand information from an image by using the brand detection feature. Here you can see an example of the JSON from including image analysis features in an image processing request. So we see the confidence, we see the bounding box variables, and also in text, a trailer with a door and windows. Again, the confidence level and the bounding box. Azure AI provides two different features that read text from documents and images, one in the Azure AI Vision service, the other in the AI Document Intelligence. There is an overlap in what each service provides. However, each is optimized for results depending on what the input is. You can access both technologies, guess how, by REST API or a client library. Use the Read API to extract printed and handwritten text in supported languages from images, PDFs, and TIFF files. The optical character recognition OCR capability supports both images and documents with mixed languages and doesn't require specifying the language. The new Azure AI Vision Image Analysis 4.0 REST API offers the ability to extract printed or handwritten text from images in a unified performance-enhanced synchronous API that makes it easy to get all the image insights, including OCR results, in a single API operation. Cool. The Read OCR engine is built on top of multiple deep learning modules supported by universal script-based models for global language support. For all of this and other related topics, make sure to try out the quick starts on the Azure Docs in this topic. For this topic, just search Quick Start Image Analysis 4.0 and you'll find that. You can now create and train your own custom image classification and object detection models using Vision Studio or the version 4.0 REST APIs. Model customization lets you train a specialized image analysis model for your own use case. Custom models can do either image classification, tags applied to the whole image, or object detection, tags applied to specific areas of the image. Once your custom model is created and trained, it belongs to your Vision resource, and you can call it, guess what, using an Analyze Image API. Image Analysis 4.0 lets you train a custom model using your own training images. By manually labeling your images, you can train a model to apply custom tags to the images or image classification and detect custom objects, object detection. Image Analysis 4.0 models are especially effective at few-shot learning, so you can get accurate models with less training data. After training has completed, you can view the model's performance evaluation in the studio at https://portal.vision.cognitive.azure.com. Great place to go check out to help you learn for this exam. The following metrics are used: image classification, average precision, accuracy top 1, accuracy top 5, object detection, mean average precision at 30, at 50, mean average precision at 75. If an evaluation set isn't provided when training the model, the reported performance is estimated on part of the training set. It's strongly recommended to use an evaluation data set using the same process as above to have a reliable estimation of your model performance. After testing the model, you can publish and use the model for inference. Based on the model's performance, you need to decide if the model is appropriate for your use case and business needs. Here's an approach you might want to take. You can deploy a customization model in an isolated environment, test the performance of the model relative to your use case, and then use predictions to further train the model until it reaches the level of performance you want. Video search and summarization use a combination of natural language processing and computer vision techniques to analyze the content of the video. It can quickly and concisely summarize the main points of a video, and it also allows you to search for specific moments within the video, making it easy to find relevant content. Azure AI Vision can suggest tags for an image based on its contents. These tags can be associated with the images as metadata that summarizes attributes of the image and can be useful if you want to index an image along with a set of key terms that might be used for search for images with specific attributes or contents. You can use Azure AI Vision spatial analysis to detect the presence and movements of people in video. Ingest video streams from cameras, extract insights, and generate events to be used by other systems. The service can do things like count the number of people entering a space or measure compliance with a face mask or social distancing guidelines. By processing video streams from physical spaces, you're able to learn how people use them and maximize the space's value to your organization. This can also do things like entrance counting, social distancing, and mask detection, as we said. Think about the scenarios like Amazon Go, or some of the things I know that Kroger has been working on to analyze the traffic patterns, how many objects are in the store. Then they could use those things for inventory automation. So really cool stuff in analyzing videos. There you have it. Wasn't too bad. That's Module 3, Implement Computer Vision Solutions. Stay tuned. Next up will be a long one. Next time we come around, we'll break it up into 2 sections. Again, I like to keep these nice and short and sweet so you can kind of study them as little learning bites. Listen to them again over and over again. Pause, repeat, go through it. This is getting the extra 3 to 5 points to hopefully tip you over so you pass the exam too. See you next time on Implement Natural Language Processing Solutions.